Hello friends, how are you? Hope you all are fine. This is another tutor marked assignment. The course code is MCO022. Course title is Quantitative Analysis and Managerial Application. Assignment code is MCO022 TMA for the session of 2022 and 23. Okay, coverage all blocks. You have to attempt all the questions. And this paper is of the maximum marks of 100. First question is discuss some criteria where the probability associated with the associated outcome is not known. Risk refers to the situation when there is more than one possible outcome of a decision and probability of each outcome is either known or can be estimated. Therefore, to measure the degree of risk, we need to know the probability of each possible outcome of a decision. Probability means the livelihood of occurring of an event. Thus, if possibility of an outcome occurring is 1 by 4 or 0.25, this means that there is one chance in 4 or 25% chances for the outcome to occur. For example, suppose a person is considering to invest in a company which is engaged in the new exploration of offshore oil. If the exploration is successful, the price of company's stock will rise to rupees 50 per share, and if exploration meets with the failure, the company's stock will fail to rupees 10 per share. Given these two possible outcomes, namely rupees 50 per share price and rupees 10 per share price, if the past information reveals that the chance of oil exploration being successful is 1 by 4 or 25% and chance of its failure is 3 by 4, then we say the probability of success of oil exploration is 25% and the probability of its failure is 75%. The success and failure are the two possible outcomes. Thus, probability is a number that indicates the livelihood of an event or outcome occurring. These are two concepts of probability depending on how it is measured. The first as the frequency concept of probability. If past information or data is available regarding occurrence of outcomes or events, the probability is defined as the proportion of times an outcome occurs if the situation is repeated in the long run over and over again. In general, if a situation is repeated over a large number of times, say m, and if an outcome, say x, occurs in m times, then p into x m by m, small m by capital M. Thus, in our example, we know from the past data of oil exploration that rate of success is 25%. Then the probability of getting success is 1 by 4 or 0.25. The measurement of probability based on the past experience is generally known as the objective measure of probability. But in many cases, there are no similar past situations which help us in measuring probability. In that case, the concept of objective probability is used. The subjective probability is an individual's personal view about the chance of an outcome to occur and is based on his personal judgment, experience, or knowledge about the subject and not on the frequency with which outcome actually took place in the past. Obviously, when probability is subjectively determined and not based on the past data, the different individuals will attach different probabilities to the occurrence of various outcomes and therefore they will make different choices. In whatever way the probability is arrived at, it helps us to measure two important concepts, namely expected value and variability of outcome. With the use of these two concepts, we compare the profitability of various strategies involving risk and uncertainty, which helps us to make a choice among them. Explain the purpose and methods of classification of data, giving suitable examples. Meaning of data classification. Data classification involves the organization of structured and unstructured data into logical categories. The goal is to ensure data is used in a more secure and efficient manner. Data classification enables organizations to easily locate and retrieve their data. It also facilitates better risk management, regulatory compliance, and legal discovery. Purpose of data classification. For most businesses, data classification is a necessary data hygiene exercise. Data classification ensures that companies comply with regularity compliance obligations to develop data-centric security across all levels of the enterprise. It helps businesses prioritize their data production efforts, improving data security and regulating compliance. Classification also helps to reduce costs, boost user productivity, and facilitate prompt decision making by eliminating unnecessary data. In addition, sensitive information should be stored securely and deleted from company databases after a defined period. Businesses have to create data categories and apply security rules to avoid breaking the rule. Many businesses have sensitive data in their tech networks without knowing it. Implementing the data classification and data security policies can help organizations to identify the level of security and privacy protection that should be applied to enforce the right access controls. Methods of data classification, paper based classification policy. This policy outlines how employees need to treat various sorts of data they deal with in keeping with the organization's overall approach to data security and strategy. A well defined policy will let users make intuitive and speedy decisions regarding the worth of a bit of information and which handling rules apply. For instance, who might access the information and should you use a rights management template. The difficulty without backing technology is making sure that all parties have knowledge of the policy and put it in place correctly. Automated classification policy. The technique does not involve the user, it enforces a classification policy, making sure it is consistently applied over all touch points without major education programs or communication. Classifications are put in place by solutions which rely on software algorithms, which use phrases or keywords from the content to classify and analyze it. This method is very effective where particular sorts of data are developed without user involvement, such as reports developed by ERP systems or where the information includes particular personal information that can be quickly identified, for example, credit card data. Yes, automated solution cannot interpret context and are thus open to inaccuracies and providing false positives that can annoy users and hinder business processes. They might also give false negatives that expose organizations to sensitive information loss. User driven classification policy. The data classification process could be entirely automated, yet it is more efficient if the user has control. This approach makes employees responsible for choosing the appropriate label and attaching it via a software tool at the point of editing, creating, saving, and sending. The benefit of including the user in this exercise is that their understanding of the context, sensitivity of a bit of information, and business value lets them arrive at an accurate and informed decision regarding which label to use. User driven classification is an added layer of security, often combined with automatic classification. What do you understand by time series analysis? How would you go about conducting such an analysis, forecasting the sales of a product in your firm? Time series analysis. Time series analysis is a specific way of analyzing a sequence of data points collected over an interval of time. In time series analysis, analysts record data points at consistent intervals over a set period of time rather than just recording the data points intermittently or randomly. However, this type of analysis is not merely the act of collecting data over time. Time series analysis typically requires a large number of data points to ensure consistency and reliability. An extensive data set ensures you have a representative sample size and that analysis can cut through noisy data. It also ensures that any trend or patterns discovered are not others and can account for seasonal variance. Additionally, time series data can be used for forecasting predicted future data based on historical data. Forecasting the sales of product in your firm. Relying on sales reps' opinions. Many sales managers simply ask their reps, when will this deal close and how much will it close for? While this is a method you could use to try to create a sales forecast, it's not recommended. Sales reps tend to overestimate sales forecast and there is no repeatable process to generate a consistent forecast with this method. Unfortunately, many businesses still rely on this method to estimate future sales using historical data. With this method, you use a record of your past performance under similar conditions to estimate how you will perform in the present. For example, you may know that your business typically grows at 15% year over year and you closed $100k of new business this month last year. That could lead you to forecast $115,000 of revenue this month. This method is slightly more accurate but ignores other factors that may have changed in the last year, like the number of sales reps you have or how your competitors are doing. Using deal stages, in this forecasting method, you assign a probability of closing a deal to each stage in your sales process. Then at any given time, you can multiply that probability by the size of an opportunity to generate an estimate of the revenue you can expect. This forecasting method is better still and is very popular because of its simplicity. However, it does have a weakness. It ignores the age of the opportunity. If two opportunities have booked a sales demo, but one is 3 weeks old and the other is 3 months old, are they really equally likely to close? Sales cycle forecasting. As a result, an alternate forecasting method is to use the age of the sales opportunity rather than the probability to assess the strength of the pipeline. It compares how long a deal has been in the pipeline compared to the normal length of the time to takes to close a deal. If you have different products and different sales cycles depending on whether you have had a referral or you are following up a lead from prospecting, then you will need to separate those out to get a prediction for how likely a deal is to come off. This method needs accurate data. Everything needs to be logged correctly in the CRM so you can see the kind of lead it is and how long it's been in the system. If you don't have CRM that records all of the other quickly and easily, it can require you reps to enter a lot of data. Pipeline forecasting. This method is much more accurate but still more reliant on a high quality of data. It looks at each opportunity sitting in your pipeline and analyzes it based on a number of factors, which could include age, deal type, and deal stage. This is a relatively sophisticated method, which means it's unlikely to work without custom tools which are capable of analyzing what's in your pipeline. Using a custom forecast model with lead scoring and multiple variables, this forecasting method is on a combination of all the above. It has some similarities to the pipeline forecasting method, but it has greater depth and complexity. Usually, you would need an analytics tool or advanced CRM report setup to help create these forecasts. You also need extremely good data in the first place. You are relying on your steps to enter a lot of accurate information. If you have those resources, this method of sales forecasting can be most accurate. Almost you can take into account the age of an opportunity, its current age in the sales process, the characteristics of the prospect that make them more likely to purchase, and more. What is the practical utility of the central limit theorem in applied statistics? Example 1 is economics. Economists often use the central limit theorem when using sample data to draw conclusions about a population. For example, an economist may collect a simple random example of 50 individuals in a town and use the average annual income of the individuals in a sample to estimate the average annual income of individuals in the entire town. If the economist finds that the average annual income of the individual in the sample is $58,000, then her best guess for the true average income of individuals in the entire town will be $58,000. Biology. Biologists use the central limit theorem whenever they use data from a sample of organisms to draw conclusion about the overall population of organisms. For example, biologists may measure the height of 30 randomly selected plants and use the sample mean height to estimate the population mean height. If the biologists find that the sample mean height of the 30 plants is 103 inches, then her best guess for the population mean height will be 103 inches. Manufacturing plants often use the central limit theorem to estimate how many products produced by the plants are defective. For example, the manager of the plant inlay may randomly select 60 products produced by the plant in a given day and count how many of the products are defective. He can use the proportion of defective products in the sample to estimate the proportion of all products that are defective that are produced by the entire plant. If he finds that 2% of the products are defective in the sample, then his best guess for the proportion of defective products are produced by the entire plant is also 2%. Surveys. Human resources departments often use the central limit theorem when using surveys to draw conclusions about overall employee satisfaction at companies. For example, HR department of some company may randomly select 50 employees to take a survey that assess their overall satisfaction on a scale of 1 to 10. It's found that the average satisfaction among employees in the survey is 8.5, then the best guess for the average satisfaction rating of all employees at the company is also 8.5. Agriculture. Agricultural scientists use the central limit theorem wherever they use data from samples to draw conclusions about a larger population. Briefly comment the following. Measuring variability is of great importance to advanced statistical analysis. Measures of variability are extremely important when analyzing and interpreting data. The most commonly used measures of spread include the variance and the standard deviation. Often the standard deviation is referenced more than the variance because It is a standardized measure and makes the value easier to interpret. When analyzing data, begin with an examination of the standard deviation of the values associated with individual variables. An inflated value for the standard deviation associated with the variable is the first indication that the data may contain outliers, because the calculation for the standard deviation include a squaring of deviation from the mean. Any values that reside significantly beyond the value of the mean will become even more inflated through the process of the calculation of the standard deviation. The presence of outliers is easiest to identify using a box plot or a histogram. A visual representation should always be included during an initial analysis. If you can see outliers are present in the visual representations, continue by checking the data itself out. Outliers may be input errors. If so, change them and run the analysis again. If they are not errors, logically attempt to ascertain why in certain instances you may be obtaining extreme values. Depending on your conclusions, you may wish to attempt to remove outliers using Winsorizing, trimming, or transformation. The reason why outliers may potentially pose a problem is the inflated value for the variation of the data are associated with an inflated error rate. If there is an inflated error rate, this easily staged in your analysis, it is likely that this will bias the results, making it less likely you will obtain significant results. In addition, many more advanced analyses have an assumption of equal variance amongst experimental group. If there is not found to be equal variance amongst groups, you will need to correct for this mathematically before proceeding. Failing to correct for this will bias results once again and make it less likely that your analysis will yield significant results. A measure of variability is a summary statistic that results the amount of dispersion in a data set. How spread out are the values? While a measure of central tendency describes the typical value, measures of variability define how far away the data points tend to fall from the center. We talk about variability in the context of a distribution of values. A long dispersion indicates that the data points tend to be clustered tightly around the center. High dispersion signifies that they tend to fall further away. In statistics, variability, dispersion, and spread are synonymous that denote the width of the distribution. Just as there are multiple measures of central tendency, there are several measures of variability. In this blog post, you will learn why understanding the variability of your data is critical. Then I explored the most common measures of variability: the range, interquartile range, variance, and standard deviation. I will help you determine which one is best for your data. The two plots below show the difference graphically for distributions with the same mean but more and less dispersion. The panel on the left shows a distribution that is tightly clustered around the average, while the distribution in the right panel is more spread out. Opinion polls are a very common method of gaining knowledge about consumer tastes. The, the opinion poll methods are used to collect opinions of those who possess the knowledge about the market, as such as sales representatives, professional marketing experts, sales executives, and marketing consultants. First is majority opinion can be determined without an election. Randomness helps to create more potential accuracy. Facts can help people identify thinking errors. It is highly affordable to complete. Probability theory provides us with the ways and means to attain the formal and precise expressions for uncertainties involved in different situations. Probability theory makes the use of random variables and probability distributors to access uncertain situations mathematically. In probability theory, the concept of probability is used to assign a numerical description to the livelihood of occurrence of an event. Probability can be defined as the number of favorable outcomes divided by the total number of possible outcomes of an event. Probability theory is a field of mathematics and statistics that is concerned with finding the probabilities associated with random events. There are two main approaches available to study probability theory. These are theoretical probability and experimental probability. Theoretical probability is determined on the basis of logical reasoning without conducting experiments. In contrast, experimental probability is determined on the basis of historic data by performing repeated experiments. Probability plays a vital role in many areas of scientific research. Researchers can integrate uncertainty into their research models as a way of describing their findings. This allows for a predictive distribution of findings tied to what may have been observed in the past. Randomness and uncertainty are popular themes tied to probability. In Nassim Taleb's best selling books, The Black Swan and Fooled by Randomness, the claim is made that rare events typically hold more importance than common ones because their effect size is not restricted. Also, because of their results are unlikely to be determined. The primary purpose of correlation is to establish an association between any two random variables. A correlation is a statistical measure of the relationship between two variables. The measure is best used in variables that demonstrate a linear relationship between each other. The fit of the data can be visually represented in a scatter plot. Using a scatter plot, we can generally assess the relationship between the variables and determine whether they are correlated or not. The correlation coefficient is a value that indicates the strength of the relationship between variables. The coefficient can take any value from -1 to 1. The interpretation of the values are perfect -1, perfect negative correlation. The variables tend to move in opposite direction, that is, when one variable increases, the other variable decreases. Then 0, no correlation. The variables do not have a relationship with each other. 1, perfect positive correlation. The variables tend to move in the same direction. That is, when one variable increases, the other variable also increases. One of the primary applications of the concept of finance is portfolio management. A thorough understanding of this statistical concept is essential to successful portfolio optimization. Most of the variables show some kind of relationship. For instance, there is a relationship between price and supply, income and expenditure, etc. With the help of correlation analysis, we can measure in one figure the data, the degree of relationship. Once we know that two variables are closely related, we can estimate the value of one variable given the value of another. This is known with the help of regression. Correlation analysis distributes to the understanding of economic behavior, aids in locating the critically important variables on which others depend. Progressive development in the method of science and philosophy has been characterized by increasing in the knowledge of the relationship. In nature, also, one finds multiplicity or interrelated processes. The effect of correlation is to reduce the range of uncertainty. The prediction based on correlation analysis is likely to be more variable and near the reality. Now write short note on the following. Geometric mean. In mathematics, geometric mean is the average value of mean, which signifies the central tendency of the set of numbers by finding the product of their values. Basically, we multiply the numbers all together and take the nth root of the multiplied numbers, where n is the total number of data values. For example, for a given set of two numbers such as 3 and 1, the geometrical mean is equal to under root of 3 into 1 is equal to under root of 3, which is equal to 1.732. In other words, geometrical mean is defined as the nth root of the product of n numbers. It is noted that the geometric mean is different from the arithmetic mean because in arithmetic mean we add the data values and then divide it by the total number of values. But in geometrical mean, to multiply the given data values and then take the root with the radical index for the total number of data values. For example, if we have to data, take the square root, or if we have 3 data, then take the cube root, or else if we have 4 data values, then take the fourth root, and so on. Geometric mean properties. Some of the important properties of the geometric mean are: the geometric mean for the given data set is always less than the arithmetic mean for the data set. If each object in the data set is substituted by the geometric mean, then the product of the objects remain unchanged. The ratio of the corresponding observation of the GM in two series is equal to the ratio of their geometric means. The products of the corresponding items of the GM in two series are equal to the product of their geometric mean. Oh, sorry. Where were we? Okay. Applications of geometric mean. The greatest assumption of the geometric mean is that data can be rarely interpreted as a scaling factor. Before that, we have to know when to use the geometric mean. The answer to this is it should be only applied to positive values and often used for the set of numbers whose values are exponential in nature and whose values are meant to be multiplied together. This means that there will be no zero value and negative value which we cannot really apply. Geometric mean has a lot of advantage and it is used in many fields. Some of the applications are as follows. It is used in stock indexes because many of the value line indexes which is used for financial departments use geometric mean. It is used to calculate the annual return on the portfolio. It is used to finance to find the average growth rate, which are also referred to the compounded annual growth rate. It is also used in studies like cell division and bacterial growth. Binomial distribution. In binomial probability distribution, the number of success in a sequence of an experiment where such time a question is asked for yes or no, then the Boolean valued outcome is represented either with success, yes, true, 1, or failure, no, false, 0. A single success set is also called a Bernoulli trial or Bernoulli experiment, and a series of outcomes is called Bernoulli process. Now see the properties of binomial distribution. The properties of the binomial distribution are there are two possible outcomes, true or false, success or failure, yes or no. There is n number of independent trials or a fixed number of n times repeated trials. The probability of success or failure remains the same for each trial, only the number of successes is calculated out of n independent trials. Every trial in an independent trial, which means the outcome of one trial does not affect the outcome of another trial. In probability theory and statistics, the binomial distribution is a discrete probability that gives only two possible results in an experiment, either success or failure. For example, if we toss a coin, there could be only two possible outcomes, heads or tails. And if any test is taken, then there could be only two results, pass or fail. This distribution is also called as binomial probability distribution. Rank correlation. The rank correlation is a non-parametric statistical procedure used for determining the bivariant correlation of two at least ordinal scaled attributes. Whereas two ranking sequences are compared with each other, in order to determine the size of the correlation, it is necessary to calculate Spearman's or Kendall-Taw's rank correlation coefficient. The rank correlation can be used when the prerequisite of normal distribution is excessively violated in the case of interval scaled dependent variables. The characteristics of both variables are carried over to the ranking positions. In statistics, a rank correlation is any of severe statistics that measure an ordinal association. The relationship between ranking of different ordinal variables or different rankings of the same variable, where a ranking is the assignment of the ordering labels first, second, third, etc. to different observations of a particular variable. A rank correlation coefficient measures the degree of similarity between two rankings and can be used to assess the significance of the relation between them. For example, the common non-parametrical methods of significance that use rank correlation are the Mann-Whitney-U test and the Wilcoxon-Saint rank test. An increasing rank correlation coefficient implies increasing agreement between rankings. The coefficient is inside an interval -1, 1 and assumes the value 1 if the agreement between the two rankings is perfect, the two rankings are the same, 0 if the rankings are completely independent, -1 if the disagreement between the two rankings is perfect, one ranking is the reverse of the another. Consideration in the choice of a forecasting method. To choose an appropriate forecasting method, you will need to consider the variables involved in whatever aspect of the business plan is being studied. The flow chart can be determined the different aspects of the elements involved in particular system. So let's see the flow chart. However, it also identifies the company's access to the data, which has a considerable impact on the forecasting methods that can be used. In areas of the system that are completely under the control of the company, there is a typical wealth of data as well as understanding of the different causal relationships, allowing easy adoption of forecasting methods that require this kind of information. Certain changes within system can decrease the reliability of identified patterns in past data. For example, if a new competitive strategy was adopted or a new product was introduced to the market, if it could make predictions for the future less accurate. Though changes can have a big impact if they were made recently, they will probably have little effect on short-term patterns. Instead, you will begin to see their full impact over an extended amount of time. The forecaster and the executive aiding them will need to discuss all alterations fully to determine the technique that would be most effective for their particular situation. Distinguish between the following: census and sampling methods of data collections. Census. Its meaning is a systematic method that collects and records the data about the members of the population. Sampling refers to a portion of the population selected to represent the entire group in all its characteristics. Enumeration is complete for census and partial for sampling. Study of each and every unit of the population in census, and in sampling only a handful of units of the population is to be studied. Time required, it is a time consuming process, and sampling is fast process. Cost, expensive method, economical method. Results, reliable and accurate, less reliable and accurate due to the margin of error in the data collector. Error not present depends on the size of the population. Appropriate for population of heterogeneous nature and population of homogeneous nature. One-tailed and two-tailed test of variance. One-tailed test and two-tailed test. A test of any statistical hypothesis where the alternative hypothesis is one-tailed, eight right-tailed or left-tailed. A test of a statistical hypothesis where the alternative hypothesis is two-tailed. Failed one-tailed, we use either this sign, that is greater or less sign, for the alternative hypothesis. For two-tailed, we use not equal to sign for the alternative hypothesis. When all alternative hypothesis specifies a direction, then we use a one-tailed test. If no direction is given, then we use a two-tailed test. Critical region lies entirely on either the right side or left side of the sampling distribution. Critical region is equal by the portion of the area lying in both the tails of the probability curve of the test statistic. Here the entire level significance, that is alpha, that is 5%, has either in the left tail or right tail. It splits the level of significance alpha into half. Rejection region is either from the left side or right side of the sampling distribution, and rejection region is from the both side, that is left and right of the sampling distribution. It checks the relation between the variable in a single direction. It checks the relation between the variables in any direction. It is used to check whether the one mean is different from other mean or not. It is used to check whether the two mean different from one another or not. Linear regression and non-linear regression. What is linear regression? Linear regression always uses a linear equation y is equal to a plus bx, where x is the explanatory variable and y is the dependent variable. In multiple linear regression, multiple equations are added together, but the parameters are still linear. What is a non-linear regression? If the model equation does not follow the y is equal to a plus bx form, then the relationship between the dependent and independent variables will not be linear. There are many different forms of non-linear models. A random forest regression is considered a non-linear model. Random forest models are ensemble learning methods for regression, which grow a forest of regression trees and then average the outcomes. This cannot be expressed as an equation. In regression trees, the splitting decision is based on minimizing the residual sum of squares, that is RSS. The variables which has the greatest possible reduction in RSS, residual sum of squares, is chosen as the root node. The tree splitting takes a top-down greedy approach, meaning the algorithm makes the best split at the current step rather than saving a split for better results on future nodes. Type 1 and Type 2 errors. Definition of Type 1 error. In statistics, Type 1 error is defined as an error that occurs when the sample results cause the rejection of the null hypothesis. In spite of the fact that it is true, in simple terms, the error of agreeing to the alternative hypothesis when the results can be described to chance, also known as the alpha error. It leads to the researcher to infer that there is a variation between two observations when they are identical. The livelihood of type 1 error is equal to the level of significance that the researcher sets for his test. Here the level of significance refers to the chances of the making type 1 error. Definition of type 2 error. When on the basis of data the null hypothesis is accepted when it is actually false, then this kind of error is known as type 2 error. It arises when the researcher fails to deny the false null hypothesis. It is denoted by Greek letter beta and often known as beta error. Type 2 error is a failure of the researcher in agreeing to an alternative hypothesis, although it is true. It validates a proposition that ought to be refused. The researcher concludes that the two observances are identical when in fact they are not. The livelihood of making such error is analogous to the power of the test. Here the power of test alludes to the probability of rejecting of the null hypothesis, which is false and needs to be rejected. As the sample size increases, the power of test also increases. That results in the reduction in size of making type 2 error. Now, key differences between type 1 and type 2 error are the points given below are substantial so far as the differences between type 1 and type 2 error is concerned. Type 1 error is an error that makes place when the outcome is a rejection of null hypothesis, which is in fact the true. Type 2 error occurs when the sample results in the acceptance of null hypothesis, which is actually false. Type 1 error, or otherwise known as false positives, in essence, the positive result is equivalent to the refusal of the null hypothesis. In contrast, type 2 error is also known as false negatives, that is, negative result leads to the acceptance of the null hypothesis. When the null hypothesis is true but mistakenly rejected, it is type 1 error. As against this, when the null hypothesis is false but errorless error erroneously accepted, it is type 2 error. Type 1 error tends to assert something that is not really present, that is, it is false hit. On the contrary, type 2 error fails in identifying something that is present, that is, it is a miss. The probability of committing type 1 error is a sample as the level of significance. Conversely, the likelihood of committing type 2 error is same as the power of the test. Greek letter alpha indicates type 1 error, unlike type 2 error, which is denoted by the Greek letter. Now, this is all about this video. Hope you liked the video. Thank you. Bye bye.